So I'm just going to flip forward now to the other end of the spectrum, which is the future. And I've called it the smart future because we don't really have a good name for this yet. But so there's a lot of paranoia about AI at the moment, and this is actually a little bit old, and to my regret, it's actually become a lot more reasonable. If you type this in now into autocomplete, which is those algorithms again, you get a more balanced set of options. But nonetheless, around the end of last year, this is what you got as a set of choices about what AI might do for us. So where does this come from? Well, so you go back to 1997. This is Garry Kasparov playing chess against Deep Blue, the IBM supercomputer. And as you can tell, he's just lost. He actually lost his first match in 1996, and then he lost a tournament in 1997. And at the time, this was viewed as a terrible blow for human self-esteem, because chess was viewed as being the exemplar of human intellect. It's a problem that you have to solve using rationality and deduction and all that sort of thing, and planning and strategy and so on. And even at the time, people didn't think a computer could do it. I don't think people particularly liked it when a computer could do it. Garry Kasparov certainly didn't like it, although he later wrote a lot of very thoughtful essays about the experience of playing against a machine. But that was kind of, it knocked down one of our certainties about humanity, that this was a problem that no machine would ever be able to solve, and it spoke to a very specific problem. What happened since then, of course, is that the world hasn't ended. We haven't all suddenly discovered that computers have taken over and we don't need to do anything. In point of fact, we just realized that computers are good at being computers. They're good at working out certain kinds of problem, and they're completely useless at others. So we kind of dealt with that quite happily for the last, however long. Then we get to this. So I don't know how many of you have seen this. This is do you know about Go? Yeah, okay. So this is Go, which is very popular in Korea. It's another board game which is sort of superficially similar to chess, but it's not actually particularly. The rules are simple, but they lead to a very, very complex game. It's not one that you can solve computationally. It's a game that involves intuition and creativity, or at least that's what people who play it say, and it's not computationally easy to solve. And so an approach like the one that Deep Blue took, which is essentially just to try everything and figure out the best way to go, doesn't work with this game. You can't just solve it through computation. What you can do, though, is you can build a machine that learns. And Google, well, not Google, DeepMind, which is now a subsidiary of Google, did that. I mean, they built a machine learning system, a neural network that learns from experience. And it learned in two ways. It learned from a very large database of humans playing Go. So it learned how humans play Go and what was good and bad about that and what was likely to win. Then it played itself a few million times to figure out what it thought about the chances of winning. And then it played Lee Sedol here, who was the world champion Go player. And this was kind of viewed as being the next big challenge after chess, because winning at Go involves creativity and intuition. That's what Go players will tell you. It's not just about cranking through the numbers. And so, again, no one thought a computer could do it. And well, the punchline's obvious, it did. I mean, it won 4 games out of 5. More notably than that, or not more notably than that, but particularly notable about that was that it won one of the games with a completely unprecedented move, with what Go players call a divine move, which is they get played once every few generations or so, and they completely reshape people's expectations of how you can play the game. And they're viewed as being, they're called a divine move because they're a bolt from the blue. They're not something that anyone thought you could do before. It won it the game, and that was kind of probably the thing that, even more than the fact it had won 4 games, made everybody, certainly made the Korean Go-watching public thresh with concern, worry, fear, a certain amount of anger, and so on. So Demis Hassabis, who runs DeepMind, and is the brain behind the brain, as it were, talked about creativity. So he defines creativity as being synthesizing information to make a novel idea. And that divine move, it seems to be an example of that. He talks about intuition being implicit knowledge acquired through experience that isn't expressible. So you know something, you know how to play Go, but you can't express it. Clearly, AlphaGo, the machine that did this, can't tell you how it did it. I mean, it knows something, it knows how to play, it won the game, it can't tell you how it did it. So does that make it creative and intuitive? And so these are Demis's definitions. They obviously lend themselves to what he thinks about this, but it is an interesting question. It's not just about raw computation. So this is a different phase. So that's very threatening to humans. The idea that computers could be creative or computers can be intuitive even if in an extremely embryonic state, even if with a very limited field of reference. I mean, clearly being creative intuitive at Go isn't much use for anything else in the world, but but it's a hint of something to come. And that's why I kind of put this thing up here about super creators. I think there is, it's not clear to me that what we're talking about here is just more computing. These are a different category of machine that do different things with a different kind of intelligence. And we talk about super creators. It's not impossible, although completely speculative, to talk about machines that would be super intuitors or super empathizers or super communicators in ways that we don't yet really understand. That is all speculative. It's not, nobody's really looking at any of that at the moment. But this is a new and different kind of challenge to our ideas about what humans can do. The reason I don't think that this is a reason for pessimism, this good, bad, neutral, I mean, the reason I don't think this is a grounds for pessimism is because we've sort of been here before with the computer example. So, as I said, we saw Garry Kasparov lose to Deep Blue at chess, and we didn't then spend our time, in despair for forever onwards. The other bit about it is that this is what computers used to be, or who computers used to be. So computers used to be women. That was the term given to, in this case, these are women working at NASA on flight trajectories. And the original term for computers meant women who did this with, and they were women who did this with calculators, essentially. At this point, nobody is mourning the fact that this doesn't happen anymore. Not really. We might celebrate the fact that it happened at all and that it's not been properly acknowledged in the histories of these things. But nobody's mourning the fact this doesn't happen. We're all used to the idea that computers do things that we can't do and that they're very good at certain problems, and that actually they help us out enormously in terms of certain problems. We know that computers have a domain and that they stick to it and they're good at it, and it actually only increases what humans can do. So I think the same will come to pass when you talk about these other classes of machines. So computational creativity is a newish field, and it's very nascent at the moment. I don't really know where it's going to go. This is at one end of the spectrum, so this is by an artist whose name, sorry, I've forgotten his name. But these are 3D printed sculptures. So he designed, not 3D printed, sorry, they're not 3D printed. They're designed on a computer, and he assembles them to make these sort of cathedral-like cardboard figures. And these are more complex. These are the most complex sculptures that exist anywhere. They have more facets and more features than anything else that has ever been made. And that's something that he's done with a computer. Now, the computer in that case is not an active participant. It's just something that assists him to get the job done. But there are things you can do with computers that humans themselves cannot, by ourselves, cannot do. And I think we know that. If you've ever used Photoshop, it does things you can't do. I mean, or spell check in Word for that matter. So that's one level of it. This is a second level of it. I don't know if anyone knows about this, but this was a musical that ran for 4 nights in the West End earlier this year, called Beyond the Fence. And the thing that made it notable was that every element of it was inspired by a computer. The bit at the top is by a program called the What If machine, which is run by Simon Colton, who works at Goldsmiths in New Cross. And you ask it for a plot suggestion, it gives you one. And that's the one it gave the makers of this play, or the one they selected. What if there was a wounded soldier who had to learn how to understand a child in order to find true love, which is random. That's what they basically built this musical out of. And it comes up with lots of other things that are bizarre, surprising, unexpected, novel, things that humans wouldn't necessarily think about, juxtapositions we wouldn't think about. At the moment, it's just suggestions, and then humans take it on, and almost everything about this musical was then essentially put into practice by humans. That won't be the case for long. Computers are getting pretty good at coming up with things of their own. At the moment, they don't necessarily meet our criteria for aesthetics, but I think it's probably safe to assume that it's probably fair to hope or believe that our aesthetics might change, or that the computers might get better at it. Both of those things are plausible. So I don't think that creativity or intuition are problematic. Where we would need these new classes of machine, I think, comes into thinking about problems that we don't really understand very well at the moment. So the one I wanted just to close with was just to go back to computers. So computers have helped us to understand things that we simply couldn't understand otherwise. So climate change. The Victorians could have found out about climate change in principle. They had the physics and they actually had the evidence around them to know that it was happening. What they didn't have was the data or any ability to analyze it, because they had limited data sets and they didn't have any way of analyzing them in the large. So the Victorians didn't discover climate change, although they would have understood it if they'd known about it. Of course, we do have that data, so we can do things like this. And we can see that. That's a temperature map for June. That's a temperature anomaly map. So the colors are relatively self-explanatory, but that's how much warmer than average it was across the world over the month of June. And it's fairly striking. I mean, it's, and that's an at-a-glance glimpse that you simply could not have without computers basically crunching very large numbers of amounts of data and coming up with a global picture. What we don't really have is any idea about how we're going to undo this situation. Well, we do have ideas, of course. Sorry, that's overstating the case. But this is an extremely complicated problem. This is what I would refer to as the biggest technological project of all time, really, because we've already had one which has got us to this situation. I mean, that's an uncontrolled experiment with the Earth's environment, which we've been doing for the better part of 10,000 years or so. Now we've got another one, which is to reverse all of that. There are a couple of ways we can do that. One is to cut emissions and to go green and all the rest of it, which involves lots of changes to the way that we use technology and the way that we design it, that we build it, that we work with it, and so on. There are more radical ideas like geoengineering, which is to take a much more active role in it and to own the idea that we are now responsible for the planet and that we shape it, and so on. If we were to go down either of those routes, these machines become important. So machine learning systems have turned out to be very good at managing electricity bills and managing electricity usage and energy grids and so on, because they can learn what usage patterns are like in a way that humans would struggle to and act accordingly. Google itself has cut its electricity bill by, well, it says it's cut its electricity bill by a massive chunk by using its own artificial intelligence on its electricity systems. So there's a role for them there. If you want to get into geoengineering and trying to understand the impact of that, that again is something that probably isn't going to happen with us just trying to work it out. It's an incredibly complicated problem for reasons I can go into if anyone's interested later on. But it's a political problem, a social problem, a geographical problem, an engineering problem, a technical problem. And we don't actually have very long to do it in, really, if we want to avoid the worst ends of this. So we're sort of coming to the end of the Anthropocene project, and we're about to start the post-Anthropocene project. And just by way of calling back to that hand axe, I just thought I'd point out that that's our starting point. That's kind of, where we are or where we were. So that's where we're starting from. And what we need to get to is whatever the equivalent is of our civilization compared to the hand axe. Artificial intelligence, machine learning, supercomputers, whatever. But it starts there. And that's it. Thank you.